So just like in Chapter 6, there are some data sets where working with proportions makes more sense than working with means. Like we saw earlier when we talked about the proportions of people who have certain incorrect feelings about antibiotics. Where when we want to deal with that, we have to recall our old friend the p-hat, the sample proportion, x over n. Remember, x is a number of successes, and a success is not a good thing. Success is in the binomial sense of being the thing we're looking for. But anyway, p-hat is x over n, and just like back in Chapter 6, and if you did the extra credit in Chapter 5, we're going to use the standard normal approximation here, assuming we have the right number of things in terms of p, q, n, and all of that stuff, which we do, because again, it's not trick questions. I want you to get practice here. But anyway, for these, we use the z-score. Z equals p-hat minus p over the square root of pq over n, our old standard normal friend, our old z-score type friend, to get our test statistic, in this case, when we want to compare a sample proportion to a population proportion that may or may not be true. And from there, we have our processes, which again are very familiar. I'll go through each of them just for the sake of being sure. If we want to use the p-value approach, then what we would have to do is verify our conditions, and that's free. State the hypotheses. They look very similar, but now we have p's instead of mu's. Then state our level of significance, again, given or you decide it yourself before doing anything else. Find the test statistic. Get the p-value. Find the area corresponding to the z and p, where you have to be careful about doubling if it's two-tailed. Make your decision and interpret the results. Exact same as before. On the other hand, if we want to deal with a critical value approach, very familiar, or at least it should be by this point, you verify your conditions, state the hypotheses and claim, get the alpha, and then you find critical values and a rejection region, then you get the test statistic, z-score, make your comparison, make your decision, and come up with your interpretation, where, just like before, the first and last steps in each of these processes is exactly the same for every single hypothesis test. All of the work, all of the math, all of the decisions in terms of what math to use, that's what changes, but ultimately, when you talk about setup, when you're talking about follow-through, it goes in very much the same way. So, with that in mind, we're going to finish this chapter with a couple more examples, helping you guys get the process down here with some applied context.